Hello everyone, welcome to my channel. This time around we are considering reflection of light by spherical mirrors. Spherical mirror is a mirror that has the shape of a piece cut out of spherical surface. And there are two types of spherical mirror. First one is concave mirror, which is also known as a converging mirror. And concave mirror is a spherical mirror with reflecting surface curved inward. That is the reflecting surface. This part is the reflecting surface of a concave mirror. These are the rails that are falling on the mirror. And the second type is a convex mirror, or you can as well call it diverging mirror. And this one is having its reflecting surface curved outward. So this part is the reflecting surface of a convex mirror. Okay, now let's quickly look at terms used in describing spherical mirror. First one is pole. Pole is the center of the reflecting surface of a spherical mirror. Let's quickly consider this. Now if you look at this mirror, this part is serving the position of a pole because that's the center of reflecting surface. And if you look at this one, this place is serving the purpose of the pole because that's the center of reflecting surface of the mirror. Okay, the next term we are looking at is a center of curvature. This is the center of sphere of which the mirror is part. That is the sphere where the mirror is formed from. So the center of that sphere is known as center of curvature, and the distance from that center to any part of the circumference of the sphere is known as a radius of curvature. And the next thing we are looking at here is a principal axis. Principal axis is the line from the pole through the center of curvature. That is the line that passes through the center of the mirror. Let's quickly consider this. You can see principal axis. This particular line is known as principal axis. We also have it in a convex mirror. This is principal axis. Okay. Now, moving away from that, we have principal focus. It's also known as focal point, or sometimes it is called focus. It's the image point of infinitely distant object, or you can call it the point where all rays parallel to principal axis converge after reflection. And it is the midway between the pole and the center of curvature. Let's quickly look at this. Okay, if you look at focus, it is represented with capital letter F. This is focus. You can see all rays parallel to principal axis. When they are reflected from the curved mirror, they converge at focus. So that is where we call focus, or you can call it focal point. It is represented with capital letter F. And as you can see, distance from the pole to focus is the same thing as distance from the focus to the center of curvature. That's why focus is the midway or midpoint between the pole and center of curvature, and it is the same thing in convex mirror, but the only difference is that the focus of the concave mirror is at the front or on the same side with the reflecting surface of a concave mirror, while in the case of convex mirror, the focus is on the opposite side of the reflecting surface. As you can see, this is the reflecting surface and this is the focus. That is why the focus of convex mirror is always negative, while that of a concave mirror is positive. Okay, now the distance between the pole of a mirror and the focus is what we call a focal length. In the case of a convex mirror, focal length is always negative, while in the case of a concave mirror, focal length is positive. As you can see, distance between the pole and the focus is at the front of a reflecting surface, so it is positive. Okay, let's move away from this. Let's quickly consider mirror's formula. You can see the mirror's formula. Mirror's formula is 1 over f equal to 1 over u. plus 1 over v, where f represents the focal length that we just discussed now, u is the object distance from the pole of the mirror, while v is the image distance from the pole of the mirror. All the distances are measured from the pole of the mirror. Now we want to quickly apply this mirrors formula in solving problem, but there are some facts that we need to consider before applying the mirrors formula. What are these facts? Number one, now images formed by a concave mirror may either be real or virtual, depending on position of the object, while the images formed by a convex mirror are always virtual. You need to take note of this, that is concave mirror can form either real image or virtual image. That is we are not going to really discuss how images are formed by this mirror in this video. And the second fact we need to consider is that focal length f of a concave mirror is positive, as we discussed earlier, while the convex focal length of convex lens is negative. Now the distance of virtual image is negative. That is, when image is virtual, its distance is always negative, while that of real image is positive. Now let's consider the first example that we have here. In our first example here, we have a concave mirror that has a focal length of 10 centimeter. We have to determine the image location of the object that is placed 30 centimeter from the mirror, and we have to also find the magnification of the image. Now from the equation, we have some parameters given. We have the focal length of the mirror to be 10. Also we have we have to determine the image location of an object. The object is placed 30 centimeter from the mirror, and we have to also find the magnification. How do we go about this? Now we have all our given parameters already written here, so let's see how we can solve the problem using the mirrors formula. And we are looking for v, which is image distance, so we make v the subject of the formula in this equation, and that gives us this particular one. You can as well substitute the value given into the formula and find your LCM, and you arrive at your answer. So substituting the values here, our f is 10, our u is 30, and u minus f will be 30 minus 10. That will give us 20, and that's 10 times 30 will give us 300 divided by 20. That will be 15. Now also we find our magnification. Our magnification equal to image distance over object distance. That will be 15 over 30. This is the formula for magnification. That will be 15 over 30, and that will give us 1 over 2, which is also equal to 0.5. Okay, let's go to the second example. The second example says a bottle is placed in front of a convex mirror. This time we're looking at convex mirror. The first example is about concave mirror. And the focal length of the convex mirror is 8 centimeter. An erect image 2 centimeter tall is formed 4 centimeter behind the mirror. Find the position of the object and the magnification of the image, and also the height of this bottle. Okay, there are some things we need to consider here. Number one, we are dealing with convex mirror, so our focal length will be negative. That is why we have f equal to -8. Now, second thing that we have here is that we have the image height, because the question says erect image of 2 centimeter tall, so that is why our image height hi equal to 2 centimeter. And also we have image formed behind the mirror. Once image is formed behind the mirror, that is factual image. Any image that is forming at the back of the mirror, that is factual image. That's why we recorded the value of image distance as -4. So those are the things we need to consider. Or sometimes when you have erect image is always factual. Take note of that. The word erect, when it appears, or upright, the upright or erect image is always factual. Okay, using mirrors formula and making you decide to the formula, we have this equation. Substituting all the values into this, our f is -8 multiplied by v, which is -4, and v minus f will be minus 4 minus minus 8. That will be minus 4 plus 8, and that will give us 4. So playing around that one, we have 8 as the value of object distance. Also, we are asked to find the magnification. The magnification equal to image distance over object distance, and image distance equal to 4, object distance equal to 8. So we have magnification to be half or 0.5. Okay, now the last thing that we have there is the height of the object. Remember that the formula for magnification F equal to V over U, and is also equal to image height over object height. So using that, that's why we have this magnification equal to image height over object height, and our image height is 2, while the object height is made the result of the formula, and the magnification is 0.5. It means our object height will be equal to 4 centimeter. Okay, now let's look at the last example here. Example 3 says a concave makeup mirror is designed so that a person 25 centimeters in front of it seeks an upright image at a distance of 50 centimeters behind the mirror. What is the radius of curvature of the mirror? And also, what is the magnification of the image? Okay, just before I solve this, let me quickly remind us of something. Now, when you are solving for anything here, if your unknown is, even if you are aware that your unknown should have a negative sign, you are not to put the negative sign on any unknown until you solve and you get a negative sign for that unknown. Take note of that. For a virtual image distance, if you are solving for virtual image distance, you are not to assign the negative sign to the symbol. You are to solve and get a negative value. That is very, very important. Now, from this question, we have our parameters. Our object distance from the concave mirror is 25. Now, according to the question, upright image is formed at a distance 50 centimeters behind the mirror. Either the word upright or behind the mirror is just telling us that the image is virtual. That's why we have our V equal to minus 50. Now, so we have to find the radius of curvature. Now, using the mirror's formula, we just substituted the values into the formula. So 1 over f will be equal to, that is, we have 1 over f, which will be equal to 1 over u will be 1 over 25. Now this time around, we have plus in the equation, but 50 is carrying minus, so that is why we're going to have minus 1 over 50. So finding the SCM, SM will be 50. Now 25 and 50 will be 2, while 50 and 50 will be 1. So that is what we have here. So 2 minus 1, that is 1. So we have 1 over f equal to 1 over 50, and that is why our f equal to 50 centimeter. If f equal to 50 centimeter, remember that r equal to 2f, according to what we discussed earlier in our terms used to describe spherical mirror. Okay, that's why we have r to be equal to 2 multiplied by 50, and that is 100 centimeter. And the last part of it, we were asked to find the magnification. Magnification is always image distance over object distance, or is also equal to image height over object height. And from the question, image distance is 50 and object distance is 25. That's why our magnification is also equal to 2. With this, we come to the end of this particular topic. Please, if you have any question, feel free to drop your question at the comment section, and the question will be attended to. And if the video has helped you in one way or the other, please also please help us to like the video, and as well also try to click on subscribe button. Thanks for watching.